Oh, test. Today I'm going to be teaching you a little bit about programming using the JavaScript language. And to do that, we're going to implement a very simple version of Tic Tac Toe. I've loaded the website JSFiddle here. You can go to jsfiddle.net to access it. And we're going to use this site because it allows us to interactively develop using HTML and JavaScript. So since we're focusing on JavaScript in this video, I'm just going to use a bare minimum of HTML. Basically, I'm just going to use it for display. So I'm just creating this pre-tag here, and that is all the HTML we will use. To refresh your memory, Tic Tac Toe is a game played on a 3x3 board. X's and O's take turns placing their markers on the board until one of the players has 3 markers in a row, either horizontally, vertically, or diagonally. So if we were to just draw the board, it would look somewhat like this. I'm going to be using underscores to represent available spaces on the board. Let's run this. And notice that it displays here. We have an empty board. So the graphics are not fancy or anything, and again, that's just to keep the HTML very light. So the first thing that we need to do to implement this game is thinking about what kind of features we're going to implement. To keep it very simple, we're going to assume that both X and O players are on the same computer, playing at the same time, and this will allow us to make certain assumptions that will simplify the game. So first we need to ask the user, the player, which position they'd like to play in. Even though they're using 2 coordinates would be better, more intuitive for this game, we're going to use just 1 coordinate by labeling each space 1 through 9. And when I say 2 coordinates, I mean that we could specify a row and column. For example, row 1, column 3. And that would actually equivalently be space 9 if we use the coordinates 1 through 9. And you'll see that more as we go along. But let me just add a little bit of a comment because it'll be useful later. So we're going to assume that these are the position coordinates of each of the spaces. And so we're going to ask the user which space they'd like to play into. And to get user input in JavaScript, we use the prompt function. And prompt takes an argument that's a string that will be displayed to the player. Which position would you like to play? 1 through 9. And let's just run this real quick. And that's it. Now, I answered 1, but that wasn't saved anywhere. The answer wasn't saved. And so we need to create a variable to store the result that I entered. When we define variables, we use the var keyword. Var and the name of the variable, And usually it's convention to name the variable using camel case, which is a mixture of lowercase and uppercase and capitalized words. And the value. That could be an integer or a number here, a string in the next line. And prompt will also return the string. So let's just say answer equals the value of the that is entered at the prompt. To display something in JavaScript, a message box, we can use the alert function. And the alert function takes as an argument whatever we want to display. So here we're going to ask the user what position they would like to play. We're going to store the answer and then alert the answer so that we can just confirm that we're saving it. It's very useful, especially when you're starting out, to just reconfirm your understanding. I'm going to enter 1 as the position, and I'm alerted 1. So if we were to try to use answer, it would actually be a little difficult to use because it's a string. And what we actually want is a number. We want a number from 1 to 9. So let's create a variable, num_answer. This will represent the numeric value of the answer. And there's a function that will convert a string into a number, %, and it takes the string, and it will just convert whatever we entered into a number. But what if we enter something like test? That cannot be converted to a number. Then num_answer will actually equal a special value called nan, which stands for not a number. We can check if something is nan using the isNan function. And that, again, that's not a number. If num_answer is not a number, then we will alert the position you entered is not a number. There are also a few other bad cases. Note that I said that the position should be in the range 1 to 9. So if num_answer is less than 1, we want to alert the position is too low. And likewise, if num_answer is greater than 9, alert the position is too high. And I'm going to add the position you entered just to be consistent. So let's just try that a bit. I'm going to delete this confirmation I created. And we're going to run it. Now it seems like there's a problem because the alert message wasn't shown, so let me just try to debug this. And we can see that there's a missing quote here. And update, and there you go. Which position would you like to play? Let's first enter something that's not a number. Test. Position you enter is not a number. Let's run it again. Which position would you like to play? 0. The position you entered is too low. And what if we enter 10? The position you entered is too high. Again, very important to continually test your understanding of the code you've written, even more frequently than the amount of times I've done it. Keep in mind, I'm very experienced, and I know what I'm doing here. Especially when you're writing something new that you've never implemented, you want to consistently validate what you're doing. So if we get here, then the number is valid. So we actually want to do something with it. We'll need some variables now. We need to store what's inside the board. So we're going to create a board. We're going to use what's called an array to store the items inside the board. And I'm just going to store the actual markers themselves. And we can have white space after these commas. So these could also be on the same line, but I'm just doing this for clarity. So we have 9 empty positions. When a user puts an X into one of those positions, then we'll store it in this array. So what we should do is, one other thing is we need to know who the current player is. And let's just assume we're going to start with X. X plays first. If the number is valid, then we need to change the value insert equals current player. We need to change the marker at position num_answer to current player. Something special about JavaScript, and actually this is true of most programming languages, is arrays are 0 indexed. That means we start counting at 0. So if we want the first position in the array, that is actually 0, not 1. This is a relic of how arrays were done in languages like C, where, well, I won't go into it, but it has to do with pointers, which you may have heard of. So, we see what's in we set the value of the board now, and let's just display the new board. So, what we're going to do is we're going to create a loop. This first part is the initializer, and then while I is less than 9, then plus plus. So this just means create a variable I to use in looping, and increment I on each loop until or while it is less than 9. And that's because there are 9 board positions. We're also going to use an accumulator for the board string, so we can just add to the board string. And what we want to do is add the marker at the board, and note that we have pipes as well. So let's just add some pipes. Okay. So let's update this. Okay. And finally, we'll load. Actually, I won't load that. It's a little bit of overkill. Document element by ID, and we want board, and inner HTML equals board string. So this will update the board display here. So note that there's a problem. We just display everything in a line. How can we get around that? Now, one thing I want to show you is what most beginner programmers might do in this situation. They might create a accumulator for the string and do something like this, or 0. So they might just manually list everything out because there's only 9 spaces. 6, 8. Right. So we should get the same thing that we got before. We did. Although we're missing a few spaces in the others. And so, where do you think we should add some carriage returns? It should be every 3. So let's do that. And what does it show? There we go. That's pretty much what we expect. It's a little different. Let me just make it consistent. And I could display it like we had planned, but it involves some code I don't want to really go into. So we can use this to think about how to change this loop to format the way that we want. Note that we have carriage return every 3. So we might be tempted to do this. If the index divided by 3, the remainder of that, and that the remainder is using this modulus operator, as equal to 0, then we want to add a new line. There will be problems with this, but I want to show you what happens. Note that it's slightly off, not quite right. So let's look at what we had. Note that it's when the remainder of dividing by 3 was 2 that we had a new line. So we want the remainder to be 2. And to see why this is, it might be beneficial for you to catch up on your, division and remainders, etc. In case it's not obvious. And that's pretty much what we expect. So this will actually only allow you to play 1 turn. What we want to do is keep on playing. So what we can do is create a loop. While the following is true, or while true, we'll just keep on looping forever. Repeat this stuff. I'll actually have a few problems if I leave it at true. So what I'm going to do is just replace it by a simple counter. And I won't allow us to make more than 10 moves. And this includes invalid moves, which is not quite right, but you'll see. And I'm going to add each loop. Okay, update that. And I'm just going to let it run because you can't really see what the board is updating with. So let me just run it now. Okay, so let's play 1. You can see it updated. Let's play 2. And notice X went to the 2nd spot. That's not quite right. We want to switch the player on each turn, on each valid move. So let's do that. I'm just going to continue through these. And since it's kind of hard to see the result, I'm actually going to move that lower, but I'm going to also add the board result, board display. So that we can see the board in the prompt. So we also want to switch the players. So let's do that. If the current player is equal to X, then we should actually set the current player to O. Otherwise, the current player must be X or O, so it should be X now. Okay, so let's run that. 1, 2, 3, and notice that the position, the player is changing on each play, and that's pretty much what we expect. So let's just keep on going. Oh, let me show you one problem with the code right now. Notice that if I keep on entering 1, we're just overwriting the first position. That's not right. That's not correct. So let's add another one of these. So if forward num answer -1 is equal to underscore, which is an empty space, or not equal, then we will type the position you entered has already been taken. Okay, and we need to select a different one. The other thing is each time, even when we have invalid moves, we'll still go through this part, and that's not correct. So we're going to add a final branch. If everything else, if the position was valid, then we do this part, and only if it was valid. This includes incrementing the counter. So what we can do is actually set this to 9, because there won't be more than 9 moves. There's only 9 positions. And we're only counting valid moves now. So after 9 valid moves, equivalent to the number of positions possible, we'll just stop. And if that happens, let's just alert with a corresponding message. You ran out of moves. And let's just make sure that that happens. And let's make sure we can't enter the same value. Notice that keeps on trying. And we can actually do this for a long time, because it's only counting valid moves in the loop now. Right? We are pretty far along now. The only thing that we need to do now is to detect a win. Let's do that. Firstly, I'm going to add another variable, someone1, and use this as part of the counter. And so we want to loop while less than 9 valid moves have been made and no one has won. And down here, if someone won, we want to alert and I keep on saying someone won because what we're going to do is not determine who won, just determine that someone won, because determining who won is a little more difficult. Not much, but we're trying to keep it simple. And now we're going to introduce a new concept called a function. And functions allow us to create reusable components, bodies of code. What we're going to do is we're going to pass a board here. And let me just name this something like my board, because it's not the same as this board. Could be, but within the context of the function, within its scope, it's different. So my board. We're going to return true if my board has someone who won. So there's more robust ways to check this, but for now we're just going to um, manually check all the win conditions because we know someone has won if, for example, positions 1, 2, and 3 have the same marker. So let's do that. And I'm going to renumber the spaces as they would be in the array. Remember, it's 0 index, so we start counting at 0. So this will be a little bit of a mnemonic, help us remember stuff. So if my board 0 equals my board 1, if the marker in space 0 equals the marker in space 1, and the marker in the first space equals the marker in the last space, then return true. Okay. Now one thing to keep in mind is we don't want to count spaces. So if my board 0 does not equal an empty space, and I'm going to actually change this to 1 because it's equivalent. If that is mystifying, just think about it. Think about it. So I'm just going to repeat this. These are the horizontal checks. Three, 6, 7, 4, 8, 5. Now we can do the vertical checks. So the first cell should be 0, second should be 3, and the last one should be 6. And this one should be 1, 4, 4, 1, and 7. Now here I just noticed we have a slight mistake. I fixed it. And finally, we want the last column, 2, 5, and 8. 2, and then there are 2 diagonal checks. 0, 4, and 8. And 2, 4, and 6. And otherwise, no one has won. So here, we're going to check after someone moves and just reevaluate someone has won using the function has someone won, and we're going to pass the board. That's pretty much it. So I'm not actually sure if it's going to be totally correct, but let's see. 1, 2, and 4, 5, and 7. It looks like it wasn't quite correct, so let's see what the problem is. So we didn't exit the loop when someone won. X should have won. It probably means that one of the vertical checks is bad. So let's just confirm 0, 3, 6. 1, 4, and 7. 2, 5, and 8. Well, let's try a horizontal check, because I don't immediately see what the issue is. So let's try a horizontal check. 1, 4, 2, 5, 3, 6, 8, 9. Okay, that didn't work. One thing is, we only need to evaluate someone has won once a valid move has been made, but that shouldn't be the issue. Just for sanity, a sanity check, I'm going to alert the board, and then someone has won to see what the result is. One, two, true. Okay, we see that someone has won. Should be true. So note that someone has won is true, and yet we keep on going. So obviously there's that was simple. So note that it's the variable is someone won, that someone has won. This is one of the tricky things with JavaScript. The var is actually not required sometimes, so you have to make sure that your variables are consistently named. So let's try this again. And let's run 1, 4, 2, 5, 3, so 1. And then let's try vertical match. 1, 2, 4, 5, 7. So there you go. That was a quick, simple implementation of Tic Tac Toe. I hope to describe um, more concepts in later videos, but hopefully this has given you a taste for the types of videos I might do in the future. So thanks a lot.